Washi, please let me know if you can see my screen and you can hear me.
I can see your screen. I can hear you, sir.
Hello and welcome to another wonderful day of JAMB classes, JAMB and WAEC classes. Today we're going to be looking at the subject mathematics, and we're going to be starting with the first course in mathematics from our syllabus. So we're going to be looking at number-based number basis. So number basis is normally the first topic that we'll see in our mathematics class. And it's simply a system of counting. So if you're doing software engineering coding, you're going to be able to understand that computers work with only zeros and one. And that kind of counting is known as binary, just two, binary. It's either 0 or 1. But if you're doing normal counting like in your everyday life, the normal counting is done in binary. That's 1, 2, 3 to 9. So those are the two most popular bases or way of counting. But in this class, we are going to look at other ways of counting apart from the binary and the denary. Remember, I told you binary is only zeros and one, whereas denary is 1 to 9. That automatically includes 10 because 1 is there, 0 is there. So that's how you get about 10. Okay, so let's move forward. So number basis is a system of counting in which certain units make up a bundle, and the bundle thus forms the next place value. So let's take a brighter illustration of what we are saying, okay? If the number system or the binary or the number-based system that we're using is base 10, these are the numbers that we are expected to see in our numbers. You can see this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. And this is the normal counting that we have, the denary, the base 10. That's the word number-based system. But if you come down here, you see the base 2, 0 and 1 only. That is for computer. That's the computer basic understanding of numbers. But apart from these two extremes, there are other number systems like the base 9, base 8, base 6. So if you're counting in base 9, you're supposed to have only these numbers, 0 to 8. You're not going to have 9 in it. Like if you're counting in base 10, you are having only number zeros to 9. You're not having 10. The same way, if you're counting in base 9, you're having numbers zeros to 8. You're not having 9. If you're counting in base 8, you're having numbers zeros to 7. You're not having that 8, which is the base. If you're counting in base 7, you're having numbers zeros to 6, and you're not having 7. So I want you to take note of how these numbers are arranged. So you can actually count in any of these number systems. And like I told you, the number system that is generally accepted the whole world is the base 10. And that's why we have all these numbers for base 10 from 0 to 9. So I'm going to ask you a question after this. So take note of what I just explained. This base 2 is the base numbering system for computer. That's what computer understands. On and off, 0 or 1, yes or no. But in our normal counting system in Nigeria, in the US, in Britain, they use what we call base 10. Because any number you want to get, you can get it from a combination of these numbers. Let's say you want 1 million. You pick only one of 1, then you pick 6 of 0. So you have 1 million. Let's say you have 956,000. That's the number you want to represent. You pick 9 here, you pick 5 here, you pick 6 here, then you pick 3 of these 0. You have 956. So this is the number base number that we use in our everyday counting. Whereas for computer, they use base 2. But apart from base 10 and base 2, there are other ways you can use in counting. And those are the ones that are listed here. Note that any base you're working on, you don't need to have that number. Like here, if you're working on base 9, you don't need to see 9 in the number collections. If you're working on base 8, you don't need to see 8. You only see numbers lesser than 8 to 0. If you're working on base 6, you only see numbers lesser than 6 to 0. If you're working on base 7, you see numbers lesser than 7 to 0, which is from 6 to 0. So take note. So these are the various number bases or various number system or various ways of counting that you can actually use for numbers. Okay, so let's move down to the next thing. Now, so just like I've already explained, the note I'm just giving you now is similar to what I've explained. It should be noted that base 2 is otherwise called binary. So when somebody says binary number, just know that he's talking about base 2. When somebody says denary, he's talking about base 10. So it should be noted that base 2 is otherwise called binary. So you can use any of these words for base 2. While base 8 is also called octal numbers, octal. So when you hear the word octal, they know that they are talking about base 8. Now, students should also know that when solving problems under number bases, it is advisable that the base being used should always be indicated in words. So take note, the base that we are considering here is base 8. So this is 143 base 8. You can see that the base is written in words, whereas the other numbers are written in their actual numerical form. So this is 23 base 4, meaning that the base is 4. And that's why you can never see 4 in these numbers because the base is 4. This is base 8. You can see numbers from 7 down to 0, but you can never see 8. So this is the right way to write it and not this way. You cannot say 143 base 8. The 8 should not be in numerals. It should be written in words. Okay. So I'm going to ask a question now. So Hannah, what number base are we considering in 2, 3 base 4? What number base are we considering here?
Base 4.
Good, base 4. So what are the kind of numbers that we are supposed to see here?
We are supposed to see 1, 2, 3.
1, 2, 3, and what? You're missing something.
0, 1, 2, 3.
Good, 0, 1, 2, 3. Those are just the numbers. If you ever see 7 here, you know that the person is wrong. So the base you're considering, you must see numbers that are less than that base down to 0. Oluwaseyi, do we understand what I'm saying?
Yes, sir.
Good. So what base are we considering here?
Base
Base
8.
8.
Good. Now, what are the numbers that we're expected to see here since we are considering base 8? Oluwaseyi.
7, 6, 5, 4, 3, 2, 1, 0.
Perfect. That is how you do it. So what is the difference between all these representation, these two representation here and these two here, Hannah?
This one here are written in number, and this one here are written in words.
Good. So the words written in number and the ones written in words, which one is the better way to represent base numbers?
The one written in words.
Perfect. Okay. So let's move forward. Now let's look at examples. Now we'll have 57010 to base 10. That is 5,706 to base 10. So it stands for 5,000. So this 5 now stands for 5,000. This 7 stands for 700. This 0 stands for 0 tenths. And this 6 stands for 6 units. So you need to understand. So this base 10 is actually denary, which is the normal way we count in the world. But we're going to look at another way of counting, which is in base 7. So I want you to also explain to me what that means. So for this 4607 to base 10, the 4, it stands for, the 4 now stands for 4,000. The 6 here stands for 600. The 0 here stands for 010. And the 7 here stands for 7 units. So you have to understand how it moves. The first one, depending on the number of digits that you have, it starts from units up to tens to hundreds to thousands if you're considering base 10. But let's take an example now. Here we are considering base 7. So you know now, okay, let me explain this first. This, if you now write out this, the way we've represented it here, we'll now have 4 times 1,000 because you're having 4,000. Then for 600, we have 6 times 100. And for tens, we have 0 times 10. And for units, we have 7 times 1. So unit is always 1, 10 is always 10, 100 is always 100, 1,000 is always 1,000. So if you put this in another form, 1,000 is the same thing as saying 10 to power 3. 100 is the same thing as saying 10 to power 2. 10 is the same thing as saying 10 to power 1. And 1 is the same thing as saying 10 to power 0. So this is another way of representing a base number. It simply tells you that any number that you have and it's in base 10, that you simply say 10 to power, you count. This is 4. The next two numbers are how many? 1, 2, 3. So it has to be 4 times 10 to power 3. Now, if you're considering 6, which is the next number, count the next two number, 1, 2. So it has to be 6 times 10 to power 2. You're considering the next number, which is 0. How many numbers are in front? It's only 1, which is 10 to power 1. Then the last number is 7. How many number is in from 0? So this is 7 times 10 to power 10. So the base is what you've written, but you raise to the power of what is in front. So let's say you're considering base 7. So it's going to be, you write the first 2 here, that is these 2. Then the base, you take it to the power of the next 2 numbers, which is only 2 numbers. So you have 7 to power 2. Then you write the next number plus the next number, which is 4. Then you take the base 7 to power what? What is following for how many number? Just 1 number. Then you write the next one, 6 times 10 times 7, which is the base. How many numbers are following 6? No number, you have 0. So this is how you express. This understanding that this is the way you can express a number given in a given base is very, very paramount in you understanding base numbers in general. Hannah, do you understand what I just explained?
Sir, I don't understand the base 7 you just explained. They said 2 times 49.
Good. When they say 2 times 49, that's why I told you to look at this one. 7 to power 2 is simply 49. Whereas 7 to power 1 is 7. And 7 to power 0 is units.
Okay.
You understand now? So this is actually what they transform to this one. So I don't want you to look at this one first. I want you to look at this representation, which is similar to how they did it for base 10. Then from there, that's when you now get to this. Hannah, is that clear?
Yes, sir.
Okay. Oluwase, I don't know whether you're following.
I'm following, sir.
Okay. So with this is very, very perfect. Now, very, very important. This is critical to you understanding anything in base number. Ability to express that very base number in normal numerals, which is actually in normal base 10. So whenever you're given a base number like this, transform this to this. And that is also converting it to base 10. When you're given a base number, this is 246 base 7, you should be able to transform this to this, and it's very simple. Write the first number 2 here, multiply it by the base, which is 7. Then count the number of numbers that are in front of 2. This is 2, so it has to be raised to number 2. Write the next number, which is 4, times it by the base, which is also 7. Then count the number of numbers that are in front of 4, which is 1. Then write the next number, which is 6. Multiply it by the base, which is 7. Count the number of numbers that are in front of 6. No number is there, which is 0. So this is it. And that is actually what they did for this. But they are now using base is 10 here. So they wrote the first number, which is 4. Multiply it by the base, which is 10. Then count the number of numbers in front of 4. 1, 2, 3. That's how they got this 3. Then plus, they read in the second number 6. Multiply it by the base, which is 10. Count the numbers in front of 6, which is 1, 2. And that's how they got 1, 2. And that's so if you just multiply this out, you get this same number in base 10. If you also multiply this and add up, you get this very number in base 7, in base 10. Hannah and Oluwase, is that clear?
Yes, sir.
Yes, sir.
Okay. Why I'm taking time and effort to explain this, because this is where you start getting it. And this is also where you start spelling it if you're going to spell it. Okay. So let's move to the next slide. So the next slide is just explaining what we've done in the previous slide. It's simply telling you to express this in terms of base 10 or in terms of number. Once they tell you to show it in normal number base or place values, it simply means express it in such a way that after that you can get the equivalent of base 10 of that number. Can you see this 476 base 8? Hannah and Oluwase, can you see that?
Yes, sir.
Okay, so this is where they represented it. Forget about this first up. This first
Yes,
two will confuse you. This is what you need to consider first. So you write 4 first. Can you see me writing 4 first? Can you see the 4 first?
Yes, sir.
So you multiply it by the base, which is 8. Abi?
Yes.
Good. Then you raise to power. How many numbers that are in front of 4? Hannah, how many numbers?
2.
2. That's why you have 2.
Sir.
Then you say plus. You write the next number is for 7, Abi? Times the base. The base is 8, Abi? So how many numbers are in front of 7?
1.
1. That's why you have 1. Then plus, you write the last number, which is 6, times the base. Abi? Then how many numbers are in front of 6?
0. No number.
No number, 0. That's why you have this. So if you use calculator now and multiply this out and solve it, anything you get is the equivalent of that, this 476 in base 10. Anything you get is the base 10 of that, of the equivalent of 476 base 8. So if they tell you to convert this number to base 10, this is what you have to write out. Then multiply, do the actual multiplication out. Then the value is what you are supposed to have in base 10. Are we clear on this?
Yes, sir. Yes, sir.
Okay. So you can see this one is, this number is in base 5. That's why they are multiplying by 5, 5. Can you see 5, 5 here?
Yes, sir.
And they are reason by the numbers that are in front of the number that you're considering at the moment. Okay. So let's move forward. So let's look at binary system. What did I say that binary system stands for?
0 and 1.
0 and 1, good. That's base 2, just 0 and 1, base 2. So binary system of base 2 counting is based on just the number 2, which includes only 0 and 1. The binary system is very important due to its use in, you know, I told you that it is used in computer application. Did I say that?
Yes, sir.
Those programmers that code what we call machine language. That's what they consider. It forms the basic principle in coding machine language. Languages that can talk straight to a hardware, straight to a computer. They need what we call machine language. But what did I say is the number system that we use in our everyday life? Who can tell me?
We use denary.
Denary, we use denary, which is base 10, isn't it?
Yes, sir.
That's why you see in your normal number system, you have 0s to 9. If you want to get 10, you combine 1 and 0, isn't it?
Yes, sir.
Good. So you have denary and binary. Those are the two most important. But other ones are also important. They find use in other areas of application. Even in computer science, you can also have hexadecimal and other octal. But the two most important are binary and denary. Are we clear on that?
Yes, sir.
Okay, so let's move forward. So this is an example of base 10 values. You can see them 0 down to anything. But this is how you convert them to base 2. You understand? This number 0 here is similar to this number in base 2. But this is in base 10, this is in base 2. 6 is the same thing as 110 in base 2, 6 in base 10. And for you to know that 6 is the same as 110, you place them in this place value. And I've taught you how to place this place value. Hannah and Oluwaseyi, did I teach how to place in this place value?
Yeah,
Yes, sir.
Yeah, I taught it because I say that since this is in base 10, if you're converting to base 2, that's the base 2 is what you're considering. So all this has to be 2, 2. And you have to multiply based on what you have. So if you're so that is how you convert it. I hope this is clear. Is it clear?
Yes.
So I can move forward, ma?
Yes, sir.
Yeah, somebody is trying to call me and it's affecting my network. Hannah and Oluwaseyi, can you still hear me?
Yes, sir.
Yes,
Okay.
sir.
So I hope you now know that all these numbers, you can get them to be in this form by converting from base 10
Yes, sir.
to base 10. Okay, so let's move forward.
Yes, sir.
Okay, other number bases. The counting in all other number bases follows a similar process, just like I told you. If you want to convert from any number base to base 10, you have to be multiplying by that base, Abby.
Yes, sir.
And you'll be raising to the power of the number of numbers that are in front of the number you're considering, Abby.
Yes, yes, sir.
Good. So that's what they are trying to explain here. So I don't want to waste time here. So let's move to the most important thing, conversion of number bases. This is what they will be asking you in JAMB. What is the value of this number in base 8, in base 10? Converting from one base to base 10 is the number one most important thing. Then number 2 will be converting from base 10 back to those numbers. So we're going to learn how to do that. Now, conversion of number bases is a process of changing one number base to another. It involves converting number from base 10 to any other base and from any other base to base 10. Conversion between bases other than 10 can also be done. Conversion from base 10 to any other base. This involves successive division. That's if you want to convert from base 10 to any other base. I had earlier told us that to convert from any other base to base 10, just place them in the place value. But if you want to convert from base 10 to any other base, you have to do what we call successive division by the base required. So at each step of the division, the remainders are recorded, including 0 until the division is completed. Then you now collect the quotients, okay? So let's practice this so that you understand it. Now, how can you convert 124 base 10 to base 8? Hannah and Oluwaseya, are you guys listening?
Yes, sir.
Yes, sir.
Okay, if you had wanted to convert from base 8 to 10, you just do that multiplication that I showed you people before. Do you understand that?
Yes.
So
Yes,
when
sir.
you solve out any value you have, that's the conversion. But if you're converting from base 10 to any other base, you have to continuously divide that number by that base that you're converting to. So here you're converting to base 8. That's why you're continuously dividing by base 8. But when you're dividing, what you're finding out is the remainder. If you collect the remainder from down up, anything it gives you is the word converted number. I don't know whether you understand this.
I'm following, sir.
You're following, okay. So let's take a typical example now. This is 124. If you use your calculator and press 124 divided by 8, you're gonna get 15 point something. Can somebody press a calculator? 124 divided by 8. What did you get?
$15.5.
Good, it's 15 point something. So you must write that 15. You understand? So remainder is what you are going to, but if you use computer to press it, the remainder is not likely. What you do, if you want to get the actual remainder, you say you got 15 point what?
15.5. 5.
Good. So if you do that 0.5, which is the remainder, times 8, you will now get the normal number of remainder. Do 0.5 times 8. What did you get?
Four.
4. Good. So that's how you get
Sir.
the actual remainder. Can you see that? So do
Yes,
you
sir.
understand how we did this now? Okay. So I want you to also do 15 divided by 8. What will you get? You will get 1 point something.
1.825. 875.
1 point what?
875.
So you write that one. You understand? Then if you want to know the actual, remember you did now 0.875 that you got times 8. What will you give it? It will give you 7.
7.
7 back. Good. That's why you have here.
Yes.
Then if you now do 1 divided by 8, you know that 8 is bigger than 1. So 1 divided by 8 cannot even work. So that's why you say 0 remainder. That's 1. So if you now collect all this, your remainder from down to up, that is the equivalent conversion of that number 124 base 10 in base 8. Do we understand this?
Yes, sir.
Is it clear?
Yes, sir.
Okay, let's move down to the second one, which will also throw more light to what we have. So it says express 427 base 10 to base 5. This is actually base 10. Please. I'm going to write the 10. Click on it, and I'm going to reduce it to base. Can you see that? 437 in base 10. We want to convert it to base 5. So what do we do? Because we are converting to base 5, so we have to repeatedly divide that number by base 5. So I want you to do for me 437 divided by 5. What will you get? You get 87 point something. Can you try it out?
87.4.
Good, 87.4. So you write that 87. Then that 0.4 is 0.4. So do 0.4 times 5. What will you get? That should be the remainder.
2.
2. That's why you have 2. So I want you to also do 87 divided by 5. You get 17 point something.
17.4.
17.4, ba? Then do 0.4 times 5. The remainder should be what?
2.
Good. Now I want you to do 17 divided by 5. You get 3 point something.
3.4.
Good. You write the 3. Then that 0.4 times 5. What will you get?
2.
And that's the actual remainder. Now you now do 3 divided by 5 cannot go. Or you can also say 3 divided by 5. If you're using your calculator, you see that you get 0 point something, Abi.
0.6.
Good. Now do that 0.6 times 5. You get 3. Did you get 3? The 0.6 times 5, what did you get? Oluwase, the 0.6 times 5, what did you get? Are you there? Oluwase, are you there? Okay. Maybe you're having network problems. So if you do that, you're going to get 332, 3222. And that is, if you count from down up, then you get the equivalent in base 5 of your base 10. Oluwase, are you there now?
Yes, sir.
I hope you got it, huh?
Yes, sir.
Okay, so that's how you convert from base 10 to other bases by repeated division. But if you want to convert from other bases to 10, you do that multiplication of exponential multiplication. Okay. So in the next class, we are going to be looking at, okay, conversion from base 10 to other bases. Like I said, that's what we've been doing since. The process of converting from other bases to base 10 is the converse of, that means it's the opposite of the other one we've learned. The process involves successive multiplication and power expansion until using power expansion, and that is what we use. So to convert this number to base 10, you simply write the first number, so multiply by the base, which is 2, then raise to power. How many numbers are in front of the first number? 1, 2, 3, 4, 5. So you do that for the second number, multiply by the base 2. How many numbers are in front of the second number? 1, 2, 3, 4. So down like that. So when you finish, solve them out. 2 to the power of 5 is 32. 2 to the power of 4 is 16. So 1 times 32 is 32. 1 times 16, 0 times this. So multiply out. What you get is the equivalent in base 10. Oluwase, is this clear?
Yes, sir.
Okay. So that is also what was done here. It is base 7, the same thing. 7 times 6 times 7 to the power 10. So this, if you are changing this, you're going to have the first number is 6, the base is 7. So we're going to have 6 times, the base is 7. So we have 6 times 7 all to power. How many numbers are in front of 7? 2. So I'm going to have 2, which I'm going to make an exponent. Superscript. Okay. Then I'm going to say plus the next number, So what is the next number?
2.
Can you tell me the next number, Luashe?
2.
Okay. So the next number is 2. So 2 times what?
2 times 7
What's
raised
gonna
to
be
power
times what?
1.
The base.
7
What's the
raised to
base?
power 1.
7.
7.
Okay. To power
1.
no. 1. Good. Okay. So what's the next number?
5.
Plus 5.
5.
To
Times
power what?
7.
Times 7, Abby.
Yes.
7 to power what? 0
0.
this time, Abby. Okay.
Yes.
So I'm gonna arrange it now. So I'm gonna make this one to be a superscript. I'm gonna go to font. I'm gonna go to superscript. Okay. I'm gonna also make this 0. Right click and go to font. I'm gonna make this superscript. So Luase, is that what you are supposed to have?
Yes.
Okay.
Said
So
that
you
we
can
did
now
not
do, you said?
plus. You didn't
I
add
didn't add
plus. I
plus,
thought
did you? Okay.
yes.
So let me do that. Okay. But I'm supposed to have a normal plus. But you understand what I mean there, huh?
Yes, sir.
Okay. So we have 7 to power 2 is what?
So 49.
49, isn't it? So
Yes,
when
sir.
we do 49 times 6, isn't it?
Yes,
That's
sir.
when we get this. Then for this one, 7 to power 1 is what?
7.
Good. 7 times 2,
14.
14. Good. Whereas this one, 7 to power 0 is what?
1.
1 times 5.
5.
Good. So that is how we're going to get this out. So let's do it together. So we have 6 times 49, isn't it?
Yes, sir.
Plus
2 times 7.
2 times 7, then plus 5 times 1. Is that?
Yes, sir.
Okay. So use your calculator and press 6 times 49.
294. 294.
294. 294. So we have plus. Use your calculator and press 2 times 7.
14.
14. So use your calculator and press 5 times 1.
5.
Okay. Now come down again. So press now 294 plus 14 plus 5. What do we get?
313.
Okay, 313. And it's gonna be in base what? 10.
Base 10.
Okay, and we're gonna take this 10 down to put it in base form. So I hope it's clear now, huh?
Yes, sir.
I'm gonna take this out since this is not clear. Okay. So that is how you convert from base 10 to other number or from other numbers to base 10. Are we clear on that?
Yes, sir.
Okay, conversion of a number in one base to another in another. So this is what we're going to be doing in our next class. So I want you to make sure you read what we've done. Read it, understand it, imbibe it into your system. So that when we now try converting from other numbers to other numbers, it will be very clear. And this is also very, very simple. This is a combination of converting a number in one base to another base number in base 10. then converting from that base number to another number. So let's say you're told to convert from base 5 to base 10. You already know how to convert from base 5 to base 10, Abi?
Yes, sir.
Good. Then when you now convert from base 5 to 10, then you now convert that very number that you have in base 10 back to 2.
Base 2.
You understand? So
Yes, sir.
there is no direct method of converting from base 5 to 2. You must convert first from base 5 to 10 and 10 to 2. Are we clear on that?
Yes, sir.
That's what actually happened here. So they wanted to convert from base 5 to base 2 here. So what they did was that they converted from base 5 to base 10, which is this 44. Then they now converted this 44 to base 10 by repeated division with 2 to convert it to base 2. You want to say, is that clear?
Yes, sir.
Okay. So this is actually this where they did it. And they also did it here. Okay. So this is where we're going to stop. So in our next class, we are going to just solve past questions. Okay.
Okay, sir.
I don't want to bother us with plenty past questions today because this is already enough for us to go and digest. So do I say
Okay.
see when I see? Have you gotten your flash?
No.
Wow. Why is it delaying that much? I don't know. I'll talk with your auntie. Let me know what's happening.
Okay.
Yeah, but if you're joining the class is even more important because I'm explaining it now one-on-one with you, okay?
Yes, sir.
Oh yeah. Take care. See you when I see you. Bye.
Bye, sir.